So this is a demonstration on how to build a circuit based on a circuit diagram. So let's say that we have this circuit diagram and we need to build this circuit. Now the diagram looks more complicated than it really is, so let's take a moment and understand the diagram itself. So we have four resistors connected together in some way, and these are all connected to the EMF. Now the letters A, B, C, etc., these are just to identify each node so that we can reference them later. They don't have any physical significance in terms of how the circuit behaves. If we look at this circuit carefully, we see that R1 and R3 are connected together in parallel because the left and right sides are connected together. The same is true for R2 and R4. So we could replace both of these with effective resistors, and we would then have two resistors in series with each other. And then we could replace those two resistors that are in series with another effective resistor. So these four resistors are connected together in a way that could easily be replaced with a single effective resistor, and we could calculate what the effective resistance of that effective resistor is. Now let's try to build this circuit. So the diagram tells us how all of the components need to be connected together. It does not matter what the circuit looks like. It only matters how the components are connected together. But it's often simpler to try to start out by building the circuit that looks almost identical to the diagram. So let's do that. So here I have four resistors and a battery that are all laid out in the same arrangement as the diagram. Now I just need to connect them together in the same way that the diagram shows. So for the diagram, I can see that R3 and R4 are connected together by a wire. Now they're not in series with each other because there's a junction in between them, but I can connect them directly together for now. So let's do that. And I can do the same thing for R1 and R2. Let's do that. So the diagram shows that the points G and C are connected together. In our physical setup, the point G is just on the wire connecting R3 and R4, and point C is on the wire connecting R1 and R2, so we just need to connect these wires together. We have some wires with alligator clips on them, so we'll just use one of those. Now let's look at the ends. The left side of R3 and R1 are connected together, and they are both connected to the positive side of the EMF. The right side of R2 and R4 are both connected to the negative side of the EMF. We're using a battery for the EMF, so I will just connect the left and right sides of this circuit to the positive and negative terminals of the battery. So first I'll connect the left sides of R3 and R1 to the positive terminal of the battery. I have a wire alligator clipped to the positive terminal of the battery, and I just need to clip this to R3 and R1. And now I'll do the same thing for the right side of R2 and R4. You can see I had to rearrange some of the wires a little bit, but the connections are the same. And there we have it. This is the physical circuit that is depicted by the circuit diagram. I have four resistors. This is the positive side of the battery. Here's R3 and here's R1. This is R4, here's R2. This is the point G. This is the point C. And here's the negative terminal of the battery. Again, the only thing that is actually important is the connections between the resistors and the battery. For example, this is the same circuit, even though it doesn't look like it.